Okay, so hello everyone again. This is lecture number 4 on the chapter motion in a plane. So in the previous discussion, we have just started with the uh, derivation of the formula that is for analytical method of addition of vectors. Let us understand that, and then we can move on with the discussion of problems related to it, and then move with further discussion. Okay, so let us start the derivation again. We will do a small revision, and then we can move forward. Okay, so this is lecture number 4 for motion in a plane. I'm Samir Lawankar. Let's begin our discussion. Okay, so right now we are on the sixth topic, that is vector addition, that is analytical method. Okay, so let us start with the discussion only. Just a quick recap. So we started with the introduction part, in which we understood as in what happens when we go from one dimension, that is motion in a straight line, to motion in a plane, that is, let us say in our case scenario, two dimensions x and y axis. Then in second thing, so this is how we can make an x and y axis. So basically we are working in x and y plane here. Okay, that is why it is called as motion in a plane. Okay, so this is basically a plane which we are working upon. Okay, the next thing we understood the difference between a scalar and a vector. We understood the properties, some of the properties of vectors. Then we also understood that these some of the property, in which one property included multiplication of vectors by real numbers, right? Then in the fourth point of addition and subtraction of vectors, we understood how we add the vectors graphically, how we subtract the vectors graphically, and so on. Then next thing was depending on the resolution of vectors, in which we resolve the vectors. So let's say a vector has been resolved into two components, namely lambda times a and some mu times b. Correct. And if we say it in coordinate terms, let's say in I cap and j cap terms, we can write this as equal to nothing but your ax I cap plus your ay j cap. So that is how we understood the concept of resolution of vectors. And then finally, right now we are on the vector addition with analytical method. Okay. So before this, we understood two different examples in which we found. So not only one example was explained, in which the values of your two different velocities are given to you, and you needed to calculate the value of resultant. So what we basically did, you just did under root of both those values. So in that question, we just did under root of, let's say, vr square plus vw square, right? And similarly, for finding out the value of tan theta, we similarly use this concept. Correct. So it was nothing but vr by vw. VW by VR. Okay, so it was VW by VR because x axis is VW and the rainfall was in y direction. Okay, so that is how we did the same concepts here. Now let us go back to the analytical method analogy, in which we understood, in which we are trying to understand what will be the formula derived when we are trying to add two vectors. Okay. Fine, so let's start the vector addition analytical method only. So these all things were previously completed. This was the example I was talking to about. So basically tan theta was VW by VR, and resultant was nothing but equal to under root of VR square plus VW square. Fine. Okay, so that being said, let us start again. So basically where we were, so in the previous discussion, we calculated that OS square is nothing but equal to ON square plus SN square. Correct. So this value of ON is nothing but equal to OP plus PN, right? You know what is OP? OP is nothing but your capital A. What is your PN basically? PN is nothing but equal to B cos theta. Correct. Similarly, what is SN? SN basically is your B sin theta. Okay. So what you basically need to do, you need to do A plus B cos theta whole square plus B sin theta whole square. So let us try to do that. So what we need to do, we just need to do A plus B cos theta whole square plus B sin theta whole square, right? Using the identity A plus B whole square is equal to A square plus B square plus 2AB. What can we get? What we can get? So for this expression, we can get this is equal to A square plus B cos theta whole square plus 2AB cos theta plus the expression again, it is nothing but b sin theta whole square. Fine. Moving on, what we can write? This is equal to a square. This has been obtained. Plus we can write this thing, that is 2ab cos theta. Plus, if you see clearly, we can write as nothing but b square into cos squared theta plus sin squared theta. Okay, we know that what is b square theta plus sin square theta? It is one of the trigonometric identity which equates to 1. Correct? Therefore, what we will get? We will get a square plus 2ab cos theta plus b square. Fine. So that is the expression being obtained here, which was basically the resultant value. So the square of resultant is nothing but equal to a square plus 2ab plus 2ab cos theta plus b square. Or in another terms, what we can write, this is nothing but equal to a square plus b square plus 2ab cos theta with an under root. So that is how you derive the expression or the analytical method for addition of two different vectors. Okay, so I hope it is clear. You understood this concept, how this thing came. It is ab plus b cos theta. We understood this, that is, this is b sin theta. By using a simple identity, we wrote it in this form. We just substituted this here. Then we again wrote that this was a square, this was 2ab cos theta, and then we wrote b cos theta whole square plus b sin theta whole square as b square into cos square theta plus sin square theta. This came out to be equal to 1. This is one of the trigonometric identity, and hence you can write r square is equal to a square plus 2ab cos theta plus b square. Therefore, capital R, that is resultant, is nothing but equal to, so this is basically a resultant. So resultant is nothing but equal to a square plus b square plus 2ab cos theta whole under root. Fine. Okay. So that is only been explained here. Therefore, ON is nothing but equal to a plus b cos theta. So this is your a plus b cos theta. Similarly, what is Sn? Sn is nothing but equal to b sin theta. So just this thing has been written here. This thing has been written here by using the calculation which I have done right now, just in the black screen, was equal to, that is, r square is nothing but equal to a square plus b square plus 2ab cos theta. If we remove the capital square from this side and add it on the right hand side, then we will get r is nothing but equal to under root of a square plus b square plus 2ab cos theta. Please remember, this law or this formula is also referred as or also called as law of cosines. Okay, so because why it is cosine? Because of cos theta is being involved. So this is also called as law of cosines. Okay, so please remember that and let us move forward. So that is how we derive the vector addition of two different vectors. Okay, so here the magnitude of this vector r is nothing but equal to under root of a square plus b square plus 2ab cos theta. Okay, let us move forward then. Okay, so now we are doing some more analysis here. Let us try to understand, because we are trying to derive more and more information which we can understand from the graph or the figure here. Okay, so now let us look at the triangle OSN. Okay, so for the more clarity, I will make the triangle OSN here again. So this is your OSN. So this is your O, this is your S, and this is your N. Okay, so in triangle OSN, what is the value of Sn? This Sn is nothing but equal to OS sine alpha. Please remember here, so what we are trying to do, basically this is the angle alpha which is being talked about. Okay, this is the angle alpha being talked about here. So using simple trigonometry, what we can write? What is this sine alpha? This sine alpha is nothing but equal to the ratio of Sn to OS. Correct? So otherwise, if we just put Sn on this side and multiply OS with sine alpha, we will get Sn is equal to OS sine alpha. Correct? No issue in that. So this can be written as equal to OS sine alpha. Please remember, what is alpha here? Alpha is this whole angle which the resultant makes with the x-axis, or here more generally with the a-axis, and the angle between a and b is theta. Okay, I will write it here also, so that angle between A and B is equal to theta, and angle between resultant R and X, sorry, not X, resultant R and A bar is equal to alpha. Okay, hope it is clear. So therefore what we got, that Sn is nothing but equal to OS sine alpha. We also know that what is this OS? OS is nothing but the vector R. So this can also be written as equal to R sine alpha. Correct? Here R depicts the magnitude of the vector R. Okay, fine. So we understood this first line which is written here. Now in triangle PSN, fine. So let us now try to devise triangle PSN. So let me make a triangle PSN first for more clarity. So where is triangle PSN? Okay, so this small is the triangle PSN. Okay, so this is your P, this is your S, and this is your N. Okay, so in triangle PSN, again SN is there, but this time what we can say, okay, so as you can remember, okay, so if this is your angle, yes, this is your vector A, and this is your vector B, and similarly we have made it parallel to this. It is quite clear that SP is parallel to B. Similarly, this PN is also parallel to A, correct? So we have just extended it, correct? Therefore, this angle which will be created here, that is angle SPN, will also be theta. Quite evident, because this is theta, therefore this will also be theta. Hope it is clear to you. So because the lines are parallel only, so therefore there will be no change in the angle of angle between the two lines which are being drawn. So in the first case it was A and B. In this case it will be nothing but PN and SP. Okay, fine. Therefore we can write what we can make an angle theta here also. Correct. Now this can also be said as a property of parallelogram, right? For a property of parallelogram, these both angles would be same. Okay. Okay, fine. So now in triangle PSN, what is happening? Again, we need to calculate the value of Sn. How we will calculate it? We know from trigonometry that sine theta is nothing but equal to Sn upon SP. Correct? So simple trigonometry gives you the value of Sn is nothing but equal to SP sine theta. This SP is nothing but also equal to B. So here Sn depicts the value of vector B here. Correct? So Sn is not again, so this is basically B, therefore this gives you equal to B sine theta. Okay, so quite clear from the observation that from the first expression or from the first triangle we got the value of Sn is nothing but equal to R sine alpha, and from the second expression we got the value of Sn is nothing but equal to B sine theta. Okay, hope it is clear. So that is the two expressions which we got. So because these are same, we can equate both of them. Okay, let us try equating them. Let me rub some of these informations. I think this is clear to you how this all things came. Okay, so now Sn is equal to R sin alpha and Sn is equal to B sin theta. So using these two equations, using equation 1 and equation 2, what we get? We get R sin alpha is equal to B sin theta. Correct? Now just mathematical manipulation leads to R by sin theta. R by sin theta, where sin theta is being put on this side, sin alpha is put on this side. So R by sin theta is equal to B by sin alpha. Correct? So this is the expression which we got, which is written here. Okay. Now similarly what we can write, similarly let us look at this triangle again. So PM has to be calculated, correct? So PM is equal to A sin alpha. Okay, so now let us look at this triangle here. Okay, so this is your angle P, this is your M, and this is your O. Okay, so if this is 90 degrees, then this is your alpha. Okay, so here what will be sin alpha? So sin alpha is nothing but opposite upon hypotenuse, correct? So what is the opposite to this? PM is opposite to this. So this will be equal to PM upon OP, correct? So what will get the value of PM as? PM is obtained as nothing but equal to OP sin alpha. Now we know what is the length of OP. OP is nothing but your vector P. Therefore, this is equal to A sine alpha. Clear? So now, so therefore we obtained the first expression, that is PM is equal to A sine alpha. Fine. So let me just clear this. Similarly, for calculating B sine beta, how can we calculate it? Let us look at this triangle here. Let me just make it here. So let us take this triangle, that is S, T, and M. Okay. So if this is the angle beta, correct, and this is perpendicular, so then what we can write? We can write again sine beta. What is sine beta? Sine beta is opposite upon hypotenuse. So it is nothing but your MP or PM upon SP. Correct? Using mathematical manipulations, you will get MP can also be written as PM. It is equal to SP sine beta. Correct? Now what is SP? SP is nothing but your vector B or magnitude of vector B. So it can be written as equal to B sine beta. Fine. Therefore, we obtain both these quantities, that is PM is nothing but equal to A sine alpha, and similarly PM is also equal to B sine beta. Therefore, what we can write finally? Therefore, we can write A sine alpha is equal to B sine beta. Correct? Using this, now just put sine beta on this side and sine alpha on this side. What we can get, that is A upon sine beta is also equal to B upon sine alpha. Correct? So this is the second observation which we got. Okay. So this is nothing but a gameplay of all these different triangles, and we are trying to find out something. What is the final conclusion? We are just approaching that. Okay. So let us see clearly. If you use this as equation number 3 and you use this as equation number 4, as B upon sin alpha and B upon sin alpha are same in both these scenarios, finally what we can say? We can say that using these expressions, so from equation 3 and 4, what we can get? We can get A upon sine beta. So A upon sine beta is nothing but equal to B upon sine alpha is nothing but equal to R upon sine theta. So this is the expression which we get finally, which is A upon sine beta is equal to B upon sine alpha is equal to R upon sine theta. Okay, so this is nothing but which is written here. Okay, so as these all involve theta in these, sine values in this location, in the expression, this is also called as law of sines, because this expression involved cosines here. Because this expression involved cosines here, that's why it was called as your law of cosines. And because this expression involved sines here, therefore this is called as your law of sines. Okay, so that is how we approached. Finally, we derived two different laws also, and basically we also found out the magnitude and direction of the resultant of two vectors. Okay, so basically what was the question given to us? The question only was given to us is, let us say this is the vector number A, okay, and this is some vector number B. Okay, so these were the two vectors. Okay, next thing which was given to us was the complete angle of this was theta. Okay, the resultant was at some angle alpha. Okay, and next thing was that this was at angle beta, so this is some angle beta. Okay, so if we know these all expressions, so finally we can calculate first of all the resultant. How can we calculate the resultant? Resultant is nothing but equal to A square plus B square plus 2AB cos theta, right? 2AB cos theta. And similarly, if we need to calculate the values of alpha and beta, we can calculate using the expression R upon sine theta is equal to A upon sine alpha is equal to B upon sine beta. Sorry, a little mistake. So A will have sine beta and B will have sine alpha. Okay, so that is the reverse thing being happening here. So A will have sine beta, and so A So you can remember it like this. So A will have the opposite one, that is A will have sine beta, and similarly the B will have, so this is B will have your sine alpha. Okay, so the thing which is written on the opposite side will be in its expression. Okay, so A will have sine beta in its location and B will have sine alpha in its location. Okay, so that being said, that is the end. Now let us move forward. So we have understood law of cosines also, law of sines also. Now, okay. Now let us see the discussion forward. Also, what is sine alpha? Sine alpha is nothing but equal to B by R sine theta. Okay. So using this expression only, what we can say, what is sine alpha? Sine alpha is nothing but equal to B by R into sine of theta. Correct? Now, what is tan alpha? How to obtain tan alpha? Tan alpha can be obtained as equal to Sn. So just look at this triangle. Okay, so just look at this triangle here. So if you look at this triangle clearly, what is the value of so the value of tan alpha can be obtained as Sn upon OP plus Pn. Correct? So this is your alpha, this is your S, this is your N, and this is your O. There is somewhere P here, right? So then what will be tan alpha? Tan alpha will be equal to Sn upon OP plus Pn. Using this, what we can write, we can just put everything forward here. We just calculated, when we calculated the resultant vector, we knew that Sn was nothing but equal to B sine theta. Correct? Similarly, what was OP? OP was nothing but A, and what was PN? PN was nothing but B cos theta. Okay, therefore tan alpha is nothing but equal to B sine theta upon A plus B cos theta. Okay, so that is the end. Okay, so that is how we can obtain the values of magnitude also, and we can obtain the value of direction also. So that is how we can obtain the magnitude and direction of the resultant of the two vectors. So alpha can be used to find out the direction of the resultant vector, correct? So we can say that if we know the value of alpha, this resultant vector is directed at an angle alpha to the from the x-axis, or here we can say generally that from the a vector. Okay, so therefore this is how we can obtain the direction, and this is how we can obtain the magnitude. Okay, so that being said, let's move forward. Fine, so now let us do one of the questions regarding this concept, so that our conceptual knowledge about this is quite clear. Okay, fine. So you can see the question clearly. So a motorboat is racing towards north at 25 kilometers per hour. Okay. So let us first of all make the motorboat here. So let us say this is the motorboat even explained. So this can be done as VB, correct? So this VB is nothing but equal to 25 kmph. 25 kmph. Okay. And the water current in that region is 10 kilometer per hour in the direction of 60 degree east of south. Okay. So we know the direction first of all. So how can we say this is your north, this is your south, this is your east, and this is your west. It is saying that the water current in that region is 10 km per hour. In which direction? In the direction 60 degree east of south. East of south, as in this is the direction. Okay, east of south. That means we are starting from east and then we are moving towards south. Okay, so that's why this will be your 60 degree east of south. So this will be 60 degree. Okay. If it would have been west of south, then we would have gone with the base at south and went towards left side. Okay, so because it is south is the direction. Let's say what would have been another occasion, it would have stayed in the direction of south. But now if it is not in the direction of south, they're giving some angle. So they can say angle as either west of south or east of south. Because it is giving east of south, then what we will do? We will go in the direction which is right hand side. So it is 60 degree towards east of south. So therefore, we can make the water velocity of water in this direction, which is equal to 10 kmph. Okay, so that is how this thing is made. Okay, so now just what is the thing required here? We just need to calculate the value of resultant velocity of the boat. Okay, so if we need to calculate the value of resultant velocity of boat, let us first understand the situation completely, and then we can move forward. Okay, so that was the velocity of the motorboat, correct? This was the velocity of water or the current, correct? So now we just need to calculate the value of resultant. Quite evident, the resultant would be somewhere in this direction. Okay, So we don't know the exact value, but somewhat resultant would be here. Okay. Now, so what is the formula for resultant? Resultant will be nothing but equal to under root of VW squared plus Vm squared. So VW is water, Vm is motorboat, plus 2 into Vm into VW into cos of theta. What is the angle here? This angle will be this angle, correct? This will be the angle theta. Okay. Vm is given to you in the question. Vw is also given to you in the question. So we know the expression till here. We just need to calculate the value of theta, put in the result, and we can get the answer. Okay. What is given to you in the question? If you remember correctly, this is the value which is given to you in the question. This is the value which is given to you in the question. Therefore, what we just need to do, we will put the value. So now how to calculate this angle here? So as we know that this complete angle is 180 degrees, therefore this angle will be nothing but equal to 180 degree minus 60 degree, which is equal to 120 degrees. Okay, therefore we got the value of theta as 120 degrees. Please remember what is cos 120 degrees? Cos 120 degrees nothing but equal to minus 1 by 2. Okay, so just put everything in the expression. 25 square plus 10 square plus 2 into 25 into 10 into cos 1 by 2. Calculate that expression, do a square root of it, and therefore finally we'll get the expression as approximately 22 kilometers per hour. Fine. So that is the resultant velocity of the boat. That is the resultant velocity of the boat. Fine. Now let us try to obtain the direction. How can we obtain the direction? Let us say we obtain the direction as with the terms of VB. Okay. So we are trying to find out at how much inclination is the resultant R with respect to your velocity or the north direction. Okay, so how can we say? We can directly imply the law of sines here. So what does the law of sines say? So sine phi is nothing but equal to VC by R, VC by R into sine theta. Okay, so R and sine theta are opposite to each other. R will always have a complete theta into its location, and because as you can see that this is your VC, this is your VC, so VC which is opposite. So basically we can write VC here also. So what is opposite angle to VC? It is phi. That's how we obtained here. Okay, I explained to you here also that how can we say? So A is having angle opposite to beta, correct? So A is having angle opposite to beta, and similarly B is having angle opposite to alpha. Okay, so therefore to not create any confusion, how can we understand that which angle we need to take? So the angle we took, if it was phi, then the velocity which would have taken should be opposite. So what is here opposite? This is VC. Therefore we took VC in the operation. Okay, so simple calculation, sine phi gives you VC upon R into sine theta. You know the value of VC, which is your 10. You know the value of sine theta also, that is sine 120. And you know the value of capital R also. We just calculated it here. So just put it in the expression. You get the value of sine phi as nothing but equal to 0.397. Therefore, what is phi? Phi will be nothing but equal to sine inverse 0.397. And therefore, what is the value of phi? Phi will be approximately equal to 23.4 degrees. Okay, so that has also been explained. Let's move on. So that is the complete explanation of this complete answer. Okay, so what was the question being asked here? The question was being asked to find out the result. So what was the question being asked here? The question was basically asked to find out the resultant velocity of the boat. So we calculated the magnitude also, and we calculated direction also. Okay, so magnitude was calculated as equal to approximately 22 kilometers per hour, and the direction was calculated as in terms of some angle alpha, as terms of some angle phi, which is with the vertical axis. Okay, fine. So that being said, we now understood complete phenomena of your vectors. Now let us apply every concept which we understood in the last 3 lectures, or let's say 3.5 lectures in this concept regarding your motion in a plane. Okay. Fine. So just a quick revision of everything which we have studied till now. So first of all, what we studied was there is something called as scalars and vectors. Okay. So vector is something which has a direction also and a what you can say, magnitude also. So in vectors, we have understood different types of vectors. One was your position vector. The second was your displacement vector. Okay, so third was your zero vector, and fourth was your unit vector. Okay, so these all were the major things which we understood, and we understood how to form or make the addition and subtraction graphically. Then finally, in the last discussion, we understood the formula, analytical formula, that is what is R. R is nothing but equal to A square plus B square plus 2AB cos theta. Okay, and similarly for direction also, we can use the expression that is tan alpha is nothing but equal to your B sin theta upon A plus B cos theta. Okay, so that is how we can understand. Fine. That being said, let us understand the phenomenon. Let us understand the complete concept which is written. Okay. So in this section, we shall see how to describe the motion in 2 dimensions using vectors. Okay. So let us first understand the position vector and the displacement. Okay. So position vector R of a particle, located in a plane. We can take this plane to be here x and y axis with reference to the origin. Position vector is generally being started from the origin. Here reference is taken as origin only of an xy reference frame. So reference frame here is taken as xy axis. Okay, so xy reference frame. Please remember in the chapter motion in a straight line, we understood the concept of frame of reference, correct? Frame of reference. Okay, so what was frame of reference being defined as? Anything which is in some coordinates. Let us say if I make an x, y and z coordinate system plus clock. So this is basically called as your frame of reference. So this can change with the coordinate system or from where we keep our frame of reference, correct? This frame of reference can even be moving also. This frame of reference can even be at rest also. Okay. So the position vector R of a particle P in a plane of reference to the origin of an xy frame reference is given by. How can we write this as? This can be written as R is nothing but equal to xik plus yk. I explained to you also how can this thing be arrived. So let us say we have an x-axis here, we have an y-axis here, correct? Let us say this is the position P for which we are calculating the value of position vector. How can a position vector be drawn? A position vector can be drawn by just putting a vector which starts from origin O and at this point P. Okay, this can be noted as R. What are the components of this R? Just draw perpendiculars from it. Okay, so this will land at x-axis at some point and y-axis at some point. So as the position was x and y for this, therefore this will also have x value only and this will have a y value only. As this is the direction of I cap and this is the direction of j cap, therefore position vector r bar can be written as equal to summation of something with I cap and j cap. These values are nothing but I, x and y. That is how we can write the position vector, which is nothing but equal to xi cap plus y j cap. That is the only thing which is written. Fine. Where x and y are components are, so where x and y are just the components of r along the x and y axis, or simply they are the coordinates of the object. Okay, or simply they are the coordinates of the object. Fine. So that is being said, then let us move on. Now let us try to understand our displacement here. Okay, so suppose a particle moves along the curve shown by the thick line. So let us say this is the direction of movement of the position of the object along the x and y plane. Okay, so suppose a particle moves along the curve shown by the thick line and it is at P. It is at capital P at some time T. It is at this location at some time T and P dash at some time T dash, which is written in figure P. Then what will be the displacement? We understood the definition of displacement in the chapter of motion in a straight line. So displacement is nothing but equal to final value of x minus initial value of x. So because that was motion in a straight line, therefore everything was being done in terms of your x-axis only. Okay. Now therefore here what we can say, because we are understanding this in terms of position vector, we can write that the displacement delta r is nothing but equal to, this can also be written as delta x, correct? So this delta r is nothing but equal to final value, that is r dash, because we are not writing here in terms of 2 and 1, we are writing in terms of p dash at p, so we can denote the position vector of p dash by r dash. See, it can be seen here also, this is that position p dash r dash, and for p we can write this as r, this is nothing but r dash minus r. Okay, so now just simple putting of the expression here, so r dash will be nothing but equal to x dash I cap plus y dash j cap. Similarly, what will be r? R will be x I cap plus y j cap. Correct. Now we understood in the last lecture only that how can, because of the property, commutative property and associative property shown by the vectors, we can write this expression as equal to, so let me just write here. Okay, so delta r is nothing but equal to r dash minus r. This can be written as equal to x dash I cap plus y dash j cap minus x I cap plus y j cap. Correct. Now choosing the properties, what we can write, delta r can be written as equal to x dash minus x I cap plus y dash minus y j cap. If you remember correctly, this was also the same thing which we did when we were trying to understand the situation of addition of two different vectors, let's say a plus b. So when we calculated the value of r is equal to a plus b also, there also we did the same thing. Okay, if you remember correctly. So okay, so that was another example. Let us look at this example only. Therefore, we found that this is how we can define the displacement vector. Correct. So if I say that delta r is nothing but equal to, let's say, delta rx I cap plus delta ry j cap. So using the comparison between this equation and this equation, what we can say that this delta rx is nothing but equal to x dash minus x. Similarly, the value of delta ry will be equal to y dash minus y. Okay. So that is how we can understand the displacement vector in 2 dimensions. So that is the only thing written here. So we got finally displacement as equal to delta r dash minus r, and which is directed from p to p dash. This is a very important line. How it is directed? Please look over here. So you can see that it is directed from p to p dash. Okay, so that is how this is the direction of the displacement vector. Okay. So we can write above equation in component form also. You know what is components because we understood the complete concept of resolution of vectors. So basically the two forms in which it can be resolved into, the vector and resolved into, are basically called as the component forms. Okay. So this is the just thing which we did on the black screen, and therefore what we finally got, this is nothing but equal to delta x I cap plus delta y j cap. What was delta x? Basically it was x dash minus x. What was delta y? Basically it was delta y minus y. So that was the displacement vector. So that is how we can understand the displacement vector, and that is how we can understand the velocity vector. Okay, fine. Now let us move on to understanding the concept of your average velocity. Okay, so average velocity of an object is the ratio of the displacement and the corresponding time interval. Correct. So in the concept of motion in a straight line, what we understood as average velocity, first of all, we denoted average velocity as v bar, which was nothing but equal to delta x by delta t. Correct, which we also noted as equal to nothing but x2 minus x1 upon t2 minus t1. Correct. Now let us broaden our aspects to 2 dimensions. Okay. So now what we need to write, so v bar will be nothing but equal to, in the place of displacement as delta x, what we will write, it is displacement of the position vector, that is delta r. The delta t will remain same because it is a scalar quantity. Now what is delta x? Delta r, we just calculated the value of delta r. Delta r came out to be equal to delta x I cap plus delta y j cap. Okay. So using this expression here, what we can calculate now. So delta R can be written as equal to delta X I cap plus delta Y J cap upon delta T. Correct? Now this can be written as also equal to delta X by delta T I cap plus delta Y by delta T J cap. Correct? X and T, delta X delta T and delta Y delta T are all the scalar quantities only. Okay. So now just we can express what is delta X by delta T. It is some form of velocity only. Similarly, what is delta Y by delta T? It is also some form of velocity only. Okay. So just to have a significant effect of understanding whatever is written here, we wrote this as equal to Vx, that is velocity in x direction, y plus velocity y in the z direction. Okay, so it is quite clear to understand that what is the basic advantage of using the components or the resolution of vectors. So using resolution of vectors, even the velocities in two different directions can be directly added up if we require it here. Okay, fine. So that is also been explained here. So finally what we got, the expression for velocity. We got the expression for velocity is equal to V bar, which is equal to Vx I cap plus Vy j cap. Fine. So that is also been explained. Fine. Since V bar is equal to delta R by delta T, the direction of the average velocity is in the same as that of delta R. We also found the same result for the motion in a straight line also, in which we found the direction of the average velocity was in the same direction as that of your displacement. Therefore, here also, what is the direction of delta R? The delta R is in this direction. Therefore, you can see that what is the direction of delta V bar? It is also in the same direction. Okay, so that is also been explained. So the velocity or the instantaneous velocity, please remember this was the same concept we understood in the motion in a straight line also. How it was being said? It was being said like this. So let us say we need to calculate the value of delta X delta T over a time interval. So what we will do, we will just write delta X upon delta T. Now if we need to calculate the value of instantaneous velocity, we will take a time delta T such that it is very, very small. How to write that quantity? We'll write that as equal to limit delta T tending to 0. So now this expression is nothing but called as an instantaneous velocity. Okay. If you need to expand this concept into 2D axis, so what we will say, what was the velocity which we calculated? That was equal to change in the position vector about change in time. If you need to calculate the instantaneous velocity here, what we will do? We will just try to put the value of delta T very, very close to 0. So that is the expression which we obtain for your instantaneous velocity, which is given. Okay. Also, we understood that this expression is also called as dx by dt. That is differential coefficient of x with respect to t. Similar here also we can write this expression is nothing but equal to dr by dt. That is differential coefficient of vector r with respect to t. Okay, so that is how you obtain this expression also. That is vector v is nothing but equal to limit delta t tending to 0 delta r by delta t, which can be said to be equal to dr by dt. Okay, right. So just let me read this expression here. So the velocity or the instantaneous velocity is given by the limiting value of the average velocity. So as you can see, it is the limiting value of the average velocity. Okay, as the time interval approaches 0. As the time interval approaches 0, and therefore we can write that V bar is nothing but equal to delta R by delta T, which is equal to dr by dt. Fine. Hope I made it quite clear to you. So how we obtained these all expressions. Okay. Fine. Let's move on forward. So let's understand more about velocities here. Okay. So we are trying to understand more about the situation here. We are trying to analyze how just the direction of velocity takes into place as we try to decrease the value of delta t. Okay. So let us understand that first. Okay. So let me just iterate. So the meaning of the limiting process can be easily understood with the help of figures A to D. Okay, so we will use these figures to understand what is the direction, or basically what happens when we try to decrease the value of delta T. Okay, so let us understand that. So in these figures, the thick line represents the path of an object which is at P at time t. So it is quite evident the path will always be same only. There is no difference in path. Correct? The path is same only. Now P1, P2 and P3 represent the positions of the times after time delta T1, delta T2 and delta T3. Here delta T1 is greater than delta T2 is greater than delta T3. So what does it mean? Let us take for an example that the location of P at some time t is equal to 4 seconds was being conveyed to you. Then delta T1 is, let's say, 4 seconds only. Then delta T2 was 2 seconds. No, yes, and delta T3 is basically 1 second. So that is how you are trying to decrease the value of delta T as the number goes on. Okay, so P1, P2 and P3 represent the position of the objects after times delta T1, delta T2, delta T3. So it is quite clear from the understanding also that because delta T increases, then this position vector will also increase. And as the time delta T2 keeps on decreasing, this position vector will come very, very near to the actual position vector P. The displacement vector will keep on getting small. Okay. So that being said, so what is delta R1? Delta R1, delta R2 and delta R3 are the displacements of the objects in time delta T1, delta T2 and delta T3 respectively. Quite evident because we are going from P to P1. How much time it took? Delta T1. From P to P2, it's T2. From P to P3 is delta T3. Right. So that is the amount of time in which the displacement has took place. So delta R1, delta R2, delta R3 are the displacements here. Okay, that is also explained. Next thing is the direction of the average velocity V is shown in the figure A, B and C for 3 decreasing values of delta T. So whatever be the direction of delta R1, whatever be the direction of delta R2, whatever be the direction of delta R3, the direction of velocity will always be same in that scenario. So this will be same as this will be same as this will be same as this. Moving on. So here it is written also that delta T1 is greater than delta T2 is greater than delta T3. Okay. Now, as we try to decrease the value of delta T and tends it to 0, and delta R will tend to 0 also and is along the tangent to the path. So that is the main expression which we finally need to obtain, that when delta T tends to 0, the direction of this velocity is basically tangent to the path of your movement of your object. So the direction of velocity becomes tangent to the direction of the movement of the object. So that is the main expression which we need to obtain. So as you can see clearly, as you keep on decreasing, there would come a point in which delta T is very, very small, and when you try to obtain the velocity for that very, very small value of delta R, you will obtain this value which is equal to nothing but your tangent to it. This can also be understood from this expression. So when you will understand differentiation in detail, you will get to know that dr by dt is nothing but the tangent to the path at that particular point which we are talking about. Okay, fine. So that thing being said, the direction of the velocity at any point on the path of an object is tangential to the path at that point, and is in the direction of motion. Okay, so therefore what we got, that what is the direction of velocity at any point, that is tangential to the path. So this is the path, it is tangent to it, and what is the direction? The direction is in the direction of motion. So it is always in the direction of motion only, and it is always tangent. Okay, so that is how we can understand this situation. Okay, so now what we can do, we can write this expression of V in a component form. Okay, so first of all, in the previous discussion only we understood that how can V be written. This V can be written as nothing but V bar, which is equal to limit delta T tending to 0 dr by dt, which is nothing but equal to sorry, not dr by dt, this can be written as equal to delta R by delta T which can be written as equal to dr by dt. Correct? So that is the expression here. Moreover, these all things are the previous expressions only which we obtained, right? So in the place of dr by dt, we can also write as delta r by delta t is expression. Therefore, this was the previous expression which we obtained here. Correct? So this was the expression which we can put directly there. Okay? That is delta x by delta t I cap or delta y by delta t j cap. Similarly, we can just obtain the same thing for these expression here. So we can just divide it or separate it. By separating it, we will get that this is nothing but equal to I cap times limit delta t tending to 0 del x by del t. Similarly, j cap times limit delta t tending to 0 delta y by delta t. Or again, just expressing it, we'll write v is nothing but equal to vx I cap plus v by g. Okay, so that is the same expression which we got for your velocity when we're talking about average velocity basically. Okay, so therefore, even if you talk about average velocity or you talk about the instantaneous velocity, the representation of vector is same only. Okay, just the expression may change. The here expression is a quantity which is del x by del t only, but just here the expression will be a quantity vx which is equal to limit delta t tending to 0 del x upon del t. Similarly, v will be quantity. For average velocity, it will be simply delta y upon delta t. But in the expression of instantaneous velocity, this will be equal to limit delta t tending to 0 del y upon del t. So that is only being written here. That is, this values of vx and vy is nothing but equal to dx by dt, and vy is also dy by dt. So we know that when we add the expression such that limit delta t tends to 0, we can write that expression is also equal to differential of x with respect to t, and similarly differential of y with respect to t, or differential coefficient of y with respect to t and differential coefficient of x with respect to t. Okay. So if the expression for the coordinates x and y are known as a function of time, we can use these equations to find vx and vy. Finally, if you know the value of vx and vy, what will be the velocity? Velocity will be nothing but under root of vx square plus vy square. Quite evident, as you can see from this expression also. So these are nothing but your components only. One is in x direction, one is in y direction. Okay, and the direction of v is given by the angle theta. Where what is this angle theta? This angle theta is nothing but tan theta. So using this expression only, theta is written here. So what is tan theta? Tan theta is nothing but equal to vy by vx. And therefore, theta is nothing but equal to tan inverse vy by vx. Okay, where vx, vy and angle theta are shown in the figure for the velocity vector. Okay, so that was all about today's lecture. Let me stop it here only. In the next lecture, I will start with the understanding of acceleration. Okay, so just to revise everything, just to revise the final concept which we understood, and then we can close this lecture. So we understood position vector basically for 2 dimension. I'm only talking about 2 dimension here. Okay, this position vector can be written as equal to r bar, which is nothing but equal to x I cap plus y j cap, right? Similarly, next was your displacement vector. This displacement vector can be written as equal to delta r cap, which is nothing but equal to delta x I cap plus delta y j cap. Correct? Third, which we got was velocity vector. This velocity vector can be written as v bar, which is nothing but equal to vx I cap plus vy j cap, where vx is nothing but equal to delta x by delta t and vy is nothing but equal to delta y by delta t. Similarly, for instantaneous velocity, we can write again v bar is nothing but equal to vx I cap plus vy j cap, where vx is nothing but equal to dx by dt and vy is nothing but equal to dy by dt. Okay, so these are all the expressions which we obtained in this example. We also understood the complete relation of calculation of resultant r and angle theta if we need to add two vectors, and that is the end of today's lecture. Okay, so let me stop it here only. We will understand further discussions in the next lecture. So just the course progress for you. Right now we have completed the introduction, scalars and vectors. multiplication of vectors by real numbers, addition and subtraction of vectors, resolution of vectors, and right now we have completed vector addition and we are on motion in a plane. We're understanding motion in a plane, and we will understand motion in a plane with constant acceleration, relative velocity in 2 dimension, very small topic, and then we can move on to the major part, that is projectile motion and uniform circular motion. Okay, fine. So let me stop it here only. Thank you so much for listening. We will meet in the next class.